That's pretty much what's going to be the test bed right there. Excuse me while I take a tactical pause. This is by no means part of the S258 course that they offer for Comtechs to train on the NIFC equipment, the National Interagency Incident Communications Division. That's a mouthful. We affectionately call it NIFC for short. But this is not part of the program. This is something that you learn afterwards. That's if you want. I mean, me being a radio geek, yeah, I'm going to go a little bit further and push the envelope a little bit further. And what I'm doing here is I'm going to test various base antennas, portable base antennas that I use to test out the system on an incident when everything's all deployed and everything. And there's other applications as well. Now, like I said, this is not part of the S258 course. So this is something added, you know. You get the basic training, but when it comes down to hitting the field is totally different from training. So in this case here, it's really not needed for everyone. If you don't want, it's added. Right, what you see in front of you is a Discone antenna. So I'm going to go ahead and assemble this real quick. It's supposed to be no tools needed to assemble this, and you'll see when I go through the hassle of doing this. So this comes in a somewhat of a case here. Not a case, but a tool roll bag, kind of. And you just roll it all out like this. And this is supposed to be assembled in the field real quick. Here's your center mast. Right here, and it kind of looks like a medieval mace. And all these are all the antenna elements that would fit into this screw here. So you got two sides of elements there. You got a longer piece for the cone element, and then you have a shorter piece here for your disc element here. And they just easily screws into all these little screws that are protruding from the center mast. And the case is pretty nice. It comes all, you know, with all these slots and everything, and it keeps it all tidy. So I'm going to go ahead and start populating all these spaces here with the appropriate elements there, and put it all together. So this is part of the a quick assembly for a temporary setup. This is all lightweight. This is all lightweight aluminum, but it's pretty thick compared to some of the other antennas that I've featured. As far as construction, the construction is really good, and for the price tag of approximately $1,300, $1,300, it should be made pretty well. Personally, I wouldn't pay for this, to get that right off my chest, but I acquired this somehow. I don't remember. It's been a long time. I hardly ever used it at all. Used it once. So measuring this with a luggage scale, I'm not going to use their posted weight. We have a whopping 8.5 pounds. And that to me is a bit too top heavy. 8.5 pounds on top of a mast. And we're going to go ahead and show you the mast that I'm going to use as a test bed. And that's this location right here on the driveway fence there. So I got two sections of this surplus military antenna mast. And that looks like maybe 15 feet high, and that's going to be my test bed. This is not going to change. I'm going to use two sections, and all the antennas that I'm going to test in this series is going to be this very same position. So there won't be any, what do you call it, variables. The variables will be minimized. Keep it all standardized. But 8.5 pounds on top of this thing here is doable. But for a temporary setup like a kind of stuff that we do, it's not going to hack it. I take that back. It is doable, but it's not optimal. So if you know what I mean. And each evolution that I go out on, I'm always optimizing everything: weight, efficiency, speed, performance, and it's all going to get kind of, you know, mixed together for a happy medium that satisfies all those requirements. So, right then and there, the weight issue on top of the mast is one that I'm not too keen on, just because we're temporary. I could have to tear down real quick and move base camp somewhere else, go to a spike camp, and it's a hassle. And you also could be the safety issue where because this is heavy on top, it could get loose from a guy pole or guy wires or guy ropes and topple on top of somebody. And like I said, this thing is heavy and looks like a mace. You could see how one of these things could really put a hurt on somebody if it falls on their head or something like that. And it's not practicable for me, so I'm moving on. But I'm going to use this as a test bed to compare with all the other antennas I have in my arsenal here that I want to test out for the fire season. And we're going to compare this to two Diamond D130 antennas that I have in this antenna mast that I use as a listening post and test antennas at the radio shop. Two antennas that I purchased myself, so this does not belong to anyone other than myself, including this piece of gear right here as well, the Stico Discone antenna. So we're going to compare them and see what the difference is. Like I said, this one is $1,300. The Diamond antenna is $160, $150, around that price range. A lot of difference there. But as far as performance, they're really similar, and you're not getting anything other than, you know, if anybody sticks the word tactical on anything, you know, that's another extra $1,000 to the price tag. And I think that's where this thing here is kind of marketed towards public safety people, military, and so forth, you know, disasters. And we'll see. As far as the cabling, we have one cable there feeding the thing, and it has a TNC connector on it already placed there. And to interface this with my equipment and cable, I have a TNC to N-type female adapter here. So if you're getting this antenna, you probably have to buy some sort of adapter to make the configuration. So right off the bat, I'm going to say that all these antennas that you're seeing today suck. Most of them because they're not tuned correctly, and if they were tuned to the frequency that we're interested in, they could be really good antennas, but it's not the case, and I'm moving on. This Stico Discone antenna, really like in the VHF end, it's not working very well for me either. So I'm going to go ahead and compare it to the shop antenna, the Diamond D130 series of Discone antennas that I featured on this channel for almost a decade now. I can't believe it's that long, but it's going to stack up against that benchmark that's been proven for freaking years. So here's the Diamond D130 Discone antenna that I've featured on my channel for a decade, just about. I can't believe it's been that long, and it still holds true to its claims or performance rather. So here between 1 and 2 bookmarks here or markers, we have the VHF range of 140 megahertz, which is the lower band for hams, all the way to the upper bands of public safety frequencies, 175, and usually that's the Fed side of the house. So from there to there, we have a bandwidth of minus 19 for the 140 and minus 15. Minus 12, which is like this mark right here, not this tick mark, but around here, is the cutoff point, the rule of thumb cutoff point for antennas efficiency. If you have a return loss of minus 12 dBs and worse, like minus 6 or something like that, that antenna is not performing very well. If you try to transmit on that frequency with those specs, it's going to burn up your power amplifier. So it's got to be a minus 12 or better. Minus 12, minus 19, which is typical. And that's where we're at right here. So at 140, we have minus 19, which is pretty good. And 175, it's at a minus, I call it minus 16 dBs of return loss. So I could transmit from that point to this point in between with confidence that it's not going to do nothing to my antenna. And that also would translate into you receiving a little bit better from the field as well. On the UHF side of the house, we have 412 to 463. That's the bandwidth of the UHF range for that particular antenna there. So minus 406, which is what I'm interested in, is around here. We're just barely making minus 11, minus 10 there. But I'm just going to use that for listening purposes. Later on in this series, we'll get into the devil in the details later on. So for now, this is just an overview. So that is my benchmark for what I want in Basecamp when I'm monitoring the system. And like I said, this is voluntary, gear that you want to maybe pack or not. It's up to you. It's not required for your assignments on these incidents. Here's the Stico antenna on my backyard or my driveway here with short cables. I'm looking at maybe 20 feet worth of good low loss efficient cables, LMR 400 I believe, which is very good, and it's just a shorter run than my shop antenna, which I think runs maybe 30 feet with some stuff in between like lightning protection and transitional cables and adapters and stuff, which each one of those components will downgrade that line just a slight bit. And here's the VHF side. So right here is minus 10, and I haven't changed the parameters from the diamond antenna. Everything remains the same, so we can make a apples to apples comparison here. On the VHF range, we got a minus 9 there and a minus 10 there for 175. So the bandwidth of this is probably even, well, look, it's a straight line just about from point marker 1 to marker 2. So this whole line here is a return loss of minus 10 roughly, averaging, which is pretty poor. On the UHF side of the house, it's a little bit better. We got a minus 14 at 417 and a minus 15 at 169. So it's the bandwidth of this section here is probably a little bit bigger. And around my fed frequency here that I'm interested in, 405, 406, I'll probably be within spec. So that's okay. But my VHF side of the house is not looking too good. And frankly, that's my most important one because that's what the guys on the ground, the firefighters and such, are using up there. This is more for a linking system there, a backhaul of audio to link all the repeaters out there if you have 2 or more repeaters linked up together. So the Stico antenna, for all its looks, tactical painting and robustness and everything, it's not that great, not compared to the D130 at $169. So here's $1,000 worth of, poor performance here in my driveway here with, what I have. Own antenna. Not very powerful, but that's our benchmark for this antenna right here. We'll compare it to the other ones, see what that goes. So let's check the other frequency that we got as a benchmark. And here we see roughly a level of minus 100 dBs on that control channel there, and you can hear the control channel nice and strong. Here's a better picture of that signal there. This is 452.787, and it's a really strong signal at a minus 104 or 105. Let's call it that. And that what you hear there, it sounds like a control channel for a trunking system. That's what it sounds like to me. But it's the control channel that tells all the radios out there in the field that's associated with this system or fleet to, hey, I'm the top dog, listen to me. He's the conductor. And that signal is transmitted 24/7 until it breaks. And that's what I use as a sort of reference point in testing my antennas, the ghetto way, the poor man's way. So that's for the 400 megahertz range. I couldn't find none that were in the 406 or 407 range. Those are hard to come by. So I picked the one closest to me, which was 452 here. So let's go to the weather channel, which is a constant level transmission from the National Weather Service. And that's it right there. And it's kind of weak at 116, 119, right around there. You could somewhat make it out. And that's coming out of Point Reyes over at the Bay Area near Sausalito, San Quentin, up there across the Bay Bridge there. The Golden Gate Bridge, rather. So that's the level. That's the only weather station that I get in somewhat reliably. And this is with the Stico Discone antenna. So that's my reference for this particular band, 162, which is somewhere flat in the middle of the federal NIFC frequencies that NIFC uses for the fire incidents. So that's that. So here's the wideband antenna. Sounds like crap. And we have a dB reading of minus 105 for VHF on the weather channel. We go back to that control channel, nice and strong because it's close by. And we have a minus 92. So now that we got some sort of a benchmark for our Stico antenna here, let's check out this dual band antenna here. So it goes VHF and also UHF, but the UHF is in the 450 megahertz range. It won't go down to 406, so I can't really test that out completely, but I could still use this as a benchmark in a way. So here's the resonant frequency for the dual band antenna. So on a VHF, you have this nice pronounced little curve there. And the markers are still for the Diamond D130. That's not going to change. And you can see here marker 1 and marker 2, 140 to 175, minus 3, and a minus 3 here, or let's call it 4. Poor performance on those frequency there. So the bandwidth of the VHF side of this antenna is very narrow. So here's minus 10. That's like minus 12 right here. So the bandwidth actually is from here to here for a good, efficient antenna to work, not these 2 points up here. So it's actually smaller and more narrow. Here on the UHF side of the house, we got a minus 5 and a minus 6 here. So it's even smaller than the Discone antennas that we tested so far. Plus my 106 is around right here, and I would imagine that would be minus 5 around there. So it's not going to receive very well there either. And it's not so hot right down here either. This is like maybe minus 15 right here. So that dual band antenna really... not so great. It's really old, so it's been banged around. I used it quite a bit, so this is not going to be used. But this is a comparison compared to the other 2 antennas, so not viable. So here we have the dual band antenna, and this is the National Weather Channel again in Port Reyes, and we have an average of maybe 119 around there. Doesn't sound too good. It's actually performing worse than the Stico Discone antenna on VHF. But as you can see from the spectrum analyzer, it performs a little bit worse. It's not tuned right, so that's kind of expected. So let's check the control channel. And the control channel, we have an average of 102. So it's performing even worse on that as well by 2 or 3 dBs. I would say 3 dBs. So it doesn't look like my dual band antenna will suffice for this either unless I tune it in there. But it's not going to work for me that well anyway. This is just a comparison. So here's the dual band antenna again. That's up there. Same conditions, same cable, same sections of pole into my APX. And I'm measuring the APX. And it looks like it's the weather channel is coming in at average 108 dBms. And we'll compare that to the rest. Now the control channel. The control channel is coming in at a minus 83 with my HT. So that's another comparison. And this is a good way for you to check if you have a Motorola APX radio. Rumor has it that the 4330 remote kits on the Nifc cache will have that APX radio in there for dual band, and it may have this particular feature where you could measure what's going on there. I don't know. I haven't seen it yet, and we'll see. If I get my hands on one, I'll see if we can have it kind of configured that way within reason. So here I'm going to compare a single band VHF antenna. This particular one here, from this point on up, is 5/8 wavelength antenna, which doesn't need a ground plane, but we're going to use a ground plane with it anyway. This particular setup that you see here is very similar to the Nifc antenna that you see on the mountaintops or on basecamp or whatever, what they provide for their kits. So it's as close as possible as to their setup that I could somewhat replicate here. And here, this is my own VHF antenna, similar to what they're using. It's a different model, what they use, but it should perform the same. I don't remember what I tuned this to. I remember it was for federal frequencies, so it should be like resonating between 165 to 175 around there. And we'll look at the scope to see exactly what it is and then make our comparisons. So this is going to go back on the mast there and have all the same factors as all the other antennas that we tested so far. So here's the single band, the VHF antenna, and here's the resonant frequency of it. And it's the same as all the other antennas as far as the markers, but we don't have, I moved marker 3 to 162.5 to, and that's the weather channel there. In the weather channel, we have a reading of -6 dBms, which is not very good. 140 is -3, worse. And 175 is -11, just barely making specs right around here. So actually, from this point to this point here is the bandwidth of this. It's very narrow, very narrow. 5/8 inch antennas are very narrow by nature. If this was a quarter wave antenna, this would have been from 140 to like 175, the whole VHF band plan there. It would have covered that whole thing, but those are used in vehicles. This being a no ground plane, and it's used for base camps and things like that, and very narrow width of frequency. So it's a little bit worse here. Obviously, we have no UHF spread here, since this is only a VHF antenna. This right here is a harmonic. You've seen these on the other readings, and it's a harmonic of the VHF tuning here. So they kind of follow each other there like that. So here's the recording for the SDR Play receiver. And it looks like an average of maybe 120s around there. So it's not receiving any better, if not worse, than all the other ones. Because it's not tuned to the right frequency there. The antenna itself, the bandwidth is just outside of 162.5 here for the weather channel. I think it would do okay at 165 to 175, as you can see from the spectrum analyzer. But I would not use that antenna anyway because it's a single band. I want to hear VHF and I also want to hear UHF. That's my requirement in the 405 area there. So, but as a comparison, apples to oranges or whatever, with the other antennas that we are testing, that's what it looks like there, what I have on hand. And it looks like this is not going to work for me either. Here's the APX with the receiver sensitivity sort of monitor there. And it looks like it's averaging 107, 108 on it. Mind you, this is not a calibrated, tested receiver. So, you know, take it with a grain of salt. And that's how we're going to do it out in the field. With a grain of salt and just knowing your standard or your average or your set point there. As far as SDR Play here with this guy here, again, same thing with using this receiver here, SDR Play version 1. It's not calibrated, but still you can have a reference point to kind of tell you that, okay, this is what I read yesterday, but today I'm reading this level, something went wrong. Same thing with this guy here with the HTs if you have it. And you can hear it's not performing any better. It's not really tuned to that. The return loss to it is like a -6, and that's very horrible. It should be at least a -12 to be within spec for transmitting or anything else. Anything better than -12 return loss on this guy here, and on that frequency it's not gonna play too well. But the actual Nifc frequencies that they use for their kits, it's between 165 to 174, something like that. This antenna here would definitely tune to that particular band plan. So as far as the shootout for now, the shop N130 antenna outperforms the Stico tactical antenna there. Supposedly this is for field deployment, and I'm sure it does well and everything for your application, but to me it's hype. My personal opinion on this here, $1,000 worth of hype. It's nice, it's black, it's tactical, not practical for me, but I will say that it's so robust as far as the construction. This may work pretty well down in the adverse weather areas like Florida and the Carolinas with their weather down there, hurricanes and such. So this may be an option. I don't know. Haven't worked that particular environment. But it'll still do the job and everything, but I think the Diamond 130 Discone antenna for $160 maybe or so, well outperforms this guy right here in frequency resonance, and you could probably transmit and not burn up your transmitter using that antenna. The dual band antenna here, not tuned to it, at least in the 405 area, 405 megahertz. It's 450 and above, so this wasn't any better than the Discone antenna here. My 5/8 wave length antenna here, it wasn't tuned to that frequency, 162. It'll probably work in the Nifc frequencies, but it's just a single band, and so I can't check my VHF antenna, or my UHF antenna rather, UHF frequency at 405. So I could only monitor VHF with this, which is fine, and I have done that in the past, but like I said, I want to upgrade my monitoring antenna system out there in the wildfires. This dual band may work for VHF, but it won't work for UHF. So I got 2 other antennas to test that may fit the bill or may not. So that's what's coming on next, and we'll see what happens. So there you have it.